Good morning, Extension 1. Today we're starting a new topic called graphical relationships. So we're looking at all different types of graphs and how they can be affected. Today in particular, how they're affected by taking the reciprocal. Okay, so remember the reciprocal is flipping it upside down or doing 1 over it. Okay, so if we're given the graph of something, we are now expected to know after today how to draw the graph of 1 over that original function. So let's go through some key characteristics. Some of them might be confusing at first, but after we do a few examples, you'll see how they work and why they work. The first characteristic is the x-intercepts give vertical asymptotes, and the horizontal asymptote is y equals 0. So whenever we have an unknown on the bottom of a fraction, so our unknown pronumeral on the bottom of a fraction, we get a hyperbolic nature. So when we have a hyperbolic nature, we have what we call these asymptotes, and that's what the graph's approaching, but it'll never actually touch. Why does this happen? Why do we have these asymptotes? Well, let's think about it. When we have a fraction, we know that we can't have 0 on the bottom of a fraction. Okay, so you can never have that bottom equaling 0 because it's impossible in mathematics to divide by 0. So what happens is we say, well, let's think about this. When does f of x equal 0? Because that's going to be the point where it can't happen. We can't have f of x being 0 because of that idea of 0 on the bottom of the fraction. So we say, well, when does f of x equal 0? So when does the original function equal 0? And if you think of it like that, well, we know that when we solve f of x equals 0, we get x-intercepts. So that's why our x-intercepts on the original function become asymptotes on our reciprocal. It's because that shows you where the function equals 0. On the reciprocal, we can't have that function equaling 0 because when it does equal 0, we find we have 0 on the bottom of a fraction, which we can't have. I know that's a bit to get your head around. Rewind and play that again if you need to. Then we get a horizontal asymptote at y equals 0. The reason behind that is when we have our reciprocal function of y equals 1 on f of x, there is no value, not one value, that you can sub in where x is and get an answer that this entire fraction equals 0. There's nothing you can sub in down here, whatever the function is, that will give you 0 as the entire answer, which means that y will never equal 0. And the line y equals 0 is our horizontal line on our x-axis, which gives us the horizontal asymptote. Okay? Another thing is, as we sub in big x values, so when we're putting x values in that are approaching infinity, that just means getting bigger and bigger x values, the reciprocal function is going to approach 0. Let's think about that for a second. What does that mean? Let's say that I sub in the x value of 2 into my original function. In the reciprocal, that's going to be 1 on 2. Now let's think about that. I've just plugged in x equals 2 and now it's become a half. If I then go, okay, I'm going to increase my x value because I'm approaching infinity, so I'm going to pick a bigger x value. Let's go 4. When I sub that into my reciprocal, I'm going to get 1 on 4. Notice how I went to a bigger x value, but my fraction became smaller. That's what this characteristic means. As you sub in bigger x values, your reciprocal function is going to get smaller. And same as negative x values. The further negative values you sub in, the smaller that fraction is going to be. The best example for this is your classic y equals x. So this graph here is our perfect diagonal line. And we know that if we take the reciprocal of x, it's 1 on x. We know, without even knowing today's lesson, that the graph of y equals 1 on x is that hyperbola, and it has asymptotes at y equals 0 and x equals 0. Now that makes sense, because let's think about it. The x-intercept on our original graph was at 0. So x cannot equal 0 because x is on the bottom of the fraction here. We can't have 0. So the vertical line x equals 0 is an asymptote. Now, we always know from further up that y will never equal 0. The line y equals 0 is our horizontal line. There's our second asymptote. So that's how the graph y equals 1 on x is formed. What we're going to do now is look at an example together. I've given you the function f of x equals 2x minus 1, and we're going to together sketch the reciprocal of this graph. So I've gone ahead and sketched that function already, the original f of x, and you should know how to do that. I just found the x and y intercepts and drew the line. Now let's look at all our characteristics and what we're going to do to draw the reciprocal. I'm going to start by looking at the asymptotes. So where are my asymptotes? Well, let's think about the function. We're about to draw y equals 1 on 2x minus 1. That's the graph we're about to draw because it's the reciprocal. The asymptotes. What can x not equal? So what value of x would you sub into the denominator there that would give a 0 on your denominator? Well, let's think about it. 2x minus 1 cannot equal 0. If we solve that, you'll get x cannot equal a half. And look at that. It's the x-intercept of our original graph, which was one of the first characteristics. The x-intercept of the original graph becomes the asymptote. The second asymptote is always y equals 0. Okay, that's my second asymptote, which I've already put in there for you, the horizontal line. Now we've got our two asymptotes. The next thing I want you to check for is any intercepts that your reciprocal function has. It has no x-intercepts because it has an asymptote on the x-axis. But let's check for y-intercepts. We can find a y-intercept by making x 0. So if I make x 0, I get the answer of y equals negative 1, which tells me my reciprocal function passes through at negative 1 on my y-axis. There's two more steps to check for, but they aren't relevant for this question. They are definitely relevant for harder questions. Check for any minimum and maximums on your original curve. Because our original is a straight line, there are no minimum and maximums, okay? Remember, your minimum and maximums are your smiley face and sad face. Alright, so we don't have to worry about that. And the last thing we can do on pretty tough questions is sub in a point or check for infinity. These two are not relevant for this one because it's a more basic question, but as you get to harder ones, you'll see how those last two things to check for make sense. So the idea is, now we know the asymptotes. We know where this reciprocal function passes through. We know the nature is a hyperbola, okay, because all of these reciprocal functions are hyperbolic. And we know that they have to approach the asymptotes, which gives us the graph of this. Oops, and that should be passing through a negative 1. So there's, in the blue, my graph of 1 on f of x, or 1 on 2x minus 1. Make sure in your graph that you are showing those arrows are approaching the asymptotes. They're getting closer and closer and closer. And that's it. So notice how I've created this little acronym, AIMS. So that gives me the acronym of AIMS. Every time you draw a reciprocal function, I want you to do AIMS. So now let's apply that to the next question. This one here, it gives me my original function. It's a bit harder this time. When you expand this original function, you'll get an answer of, let's see what we get when we expand. This is what I get when I expand that bracket there, which tells me it's an upside down parabola. Then you can solve it for your x and y intercepts. It's easy off the original to see your x intercepts, and then sub in x equals 0 to find your y intercepts. So that's all I did. Put my x and y intercepts on, did my upside down parabola, and I've sketched f of x. That's not what we are learning today though. We're learning how to do the reciprocal. Alright, let's follow our aims. A, asymptotes. Our x-intercepts become vertical asymptotes. That's step 1. Our horizontal asymptote is at y equals 0. Alright, we got asymptotes. Done. intercepts. There's no x-intercepts on this graph because of that asymptote at y equals 0. So let's find any y-intercepts that we may have. We can find y-intercepts by subbing in x equals 0. Let's do it. F of 0 is going to give me 0 plus 2, 1 minus 0, which is 2 timesing by 1, which gives me 2. So there's a y-intercept at 2. Interesting. All right. So now I know that I've got a y-intercept at the number 2. So it's going to help me now. Sorry, just lost my train of thought. It's going to help me now understand. I'm going to do my reciprocal graph in blue, so I know it passes through there. All right, done my intercepts. Now we do our minimum maximum. Remember the characteristic further up. It said any minimums will turn into a maximum. Any maximum turn into a minimum. We have a maximum on our original parabola here. I can find out what that value is here because I know it's 1, the axis of symmetry of that parabola, or 2, halfway in between 1 and -2, which gives me a value of -1/2. So I know there's a maximum at the x value of -1/2. Remember in the characteristics I said the maximum has the same x value, but it will have a different y value. So let's see where my new minimum is going to occur because this maximum turns into a minimum. I'm going to find where that minimum is occurring by subbing in x equals 1/2 into my reciprocal function. So my reciprocal function is 1 over x plus 2, 1 minus x. So if I sub in x equals 1/2, I get 1 over 1/2 plus 2 is 2.5, timesing by 1 minus 1/2, which is 1/2. This is going to now give me the y value for my minimum, which when you do that, you get an answer of 4 on 9. Okay, so what that is a smaller number. I'm going to plot it on here. So 4 on 9 will be down here somewhere. So this becomes a minimum. Okay, at 4 on 9, x equals 1/2. All right, so my minimum is at the point 4 on 9, negative, oh sorry, wrong way around, -1/2, 4 on 9. Okay, so what I know now is, all right, it passes through at 2. It's got a minimum here. It's got to approach the asymptote. So what I do know is it's going to look something like that. Okay, but I'm not done. There's other things happening outside of the graph on the left and the right hand side. What is happening? Okay, now is where I get to S. S for sub in a point or check for infinity. So I know as I get my bigger x values, I'm going to be approaching 0 in some way. So that means the outsides of these graphs are either going to be out here like this or underneath like that. Let's check. What can I do? S stands for sub in a point. If I sub in a point, let's pick the number 2. If I sub in the number 2, I'm going to see where my reciprocal function lies when I sub in the value of 2. So let's see. 1 over 2 plus 2, 1 minus 2. 1 over 4 timesing by -1 gives me -1/4 as my answer. So when I sub in 2, I get -1/4, which is somewhere down here, which tells me that this will be the nature of my reciprocal. And still check the other side. I'm not going to sub in -2 because I've got an asymptote there. Let's sub in -3. So now I sub in -3, do the same thing. Sub it in for x, -3 plus 2, 1 minus -3. And I get an answer of 1 over, what's that? -1 is there, and 4, -1/4. All right, so it's in the negative region. So there, in the blue, is my graph of 1 on f of x. And I followed my aims. I know it's hard to get your head around but you've got to know how to do this, and you just got to keep practicing. Go through your aims every time. So pause the video. Give this one a go. This is the last one. It's a pretty tough one, but I want you to see how you go on your own. Start by sketching your original graph. Pause it and go from here. Okay, so I've done this. What I now need to do is say, okay, this, when I expand, I'm going to get my highest power is power of 3, x to the power of 3, okay, which tells me that this function is a cubic, not a parabola. So my original function is a cubic. So what a cubic is, it means a cubic has at most 2 bumps. So usually it looks something like that, okay, 2 bumps. What that means then is I know it's going to either look like one of the two. It's going to go, oh, one other thing I will point out, and this is going to come up in a couple of topics' time, but if you have the same root to the power of 2, okay, so see how the x-intercept of -1, it's what we call a repeated root, okay, it's got a power of 2. So really, I should have another -1 there, okay. What that means is it bounces off, okay, so your curve bounces off that point. And again, in a few topics' time, we will go through that in a bit more detail. But know that for now, when you have what we call a repeated root as a power of 2, it bounces off that. So what I can see then is this graph must look something like this. At the end of the day, if you're not sure, do a table of values and sketch this graph. Or pick a point. Test the number 3 in your original function, or test the number -2 in your original function, and see whereabouts your graph lies. Otherwise, this is the graph of f of x. Now let's do our aims to draw our reciprocal. A for asymptotes. All right, I have an asymptote at 2 and -1. I have a horizontal asymptote at y equals 0. Asymptotes done. Intercepts. Let's check for our y-intercepts. I'm going to sub in the point x equals 0. Let's see what I get into the function of 1 on, 2 minus 0, and 0 plus 1. Gives me 1 on 2. So I have a y-intercept at a half, which is about here. All right, I know my reciprocal function has a y-intercept at a half. All right, next part, minimums and maximums. We've got a maximum here, and this maximum occurs at halfway between -1 and 2, so 1.5. So my graph's a little bit out of scale, but that is, oops, hang on, 1.5 is here. So like I said, I'm a little bit out of scale here, so I'm just going to put 1 about there. All right. What that means is on my reciprocal, I'm going to have a minimum occurring there where that maximum is at the x value of 1.5, but not at the same y value. So I need to sub into my function f of 1.5 into my reciprocal. When you do 2 minus 1.5 and 1.5 plus 1, you will get a y value of, what did I get? I already did this. 8 on 25, which is approximately 0.3-ish just to give me an idea. All right, so I have a minimum occurring at the x value 1.5 and the y value of 0.3, which is about here. So I know it's passing through at a half. It has a minimum occurring here, and it's got to approach the asymptote, so it's going to look like this. Nearly done. Minimax done. Now, I will just point out the minimum here, yep, it normally would at -1 turn into a maximum, but it lies on the asymptote. So the asymptote is the big overrider, so it's not going to be affected. So now I sub in my points or check for infinity, okay? So pick your points, sub them in. When you sub in at, say, sub in 3 into your reciprocal function, you'll get a negative answer, which shows you your reciprocal lies down here. Again, approaching your asymptotes. When you sub in -2, you'll get a positive answer into your reciprocal, which tells you that your graph looks like that. So, it's hard to see with everything I've got going on, but the green lines are the graph of 1 on f of x. Okay? Alright. There is a backup method. If you get stuck, you can do a table of values. So what we just drew was this graph. We just drew in green that graph. Our worst case scenario, do a huge big table of values and plot points. And that's for this entire lesson. But I strongly suggest Extension 1 students should be able to get their head around this and understand how all those characteristics work to sketch the nature of these curves. Alright, today's exercise is exercise 707. I want you to have a go at these questions that I'll write out. Okay, so 1 A, B, C, D, I, J, 2 A, C, H, I, J in the Maths in Focus textbook that we've been using. See how you go.